in order to establish this trig identity, I'm going to use a trick that I call multiplying by a fancy 1. And so what I'm going to do is take this trig expression and multiply the right side by this. Now this is what I call the fancy 1. It doesn't look like a 1, but something divided by itself is 1. And you may be thinking right now, well, where did that come from? And it's a great question. And for right now, let's just do this problem, and then we're going to see what happens. We'll talk about why this was chosen and why we might know to choose this one. Also, notice I'm going to multiply the right side by this. Normally we start with the more complicated side, although in this example I don't think either side is necessarily more complicated than the other. So my goal is to end up here. I'm not going to mess with this. I'm going to try to get to 1 minus sine over cosine by multiplying. And again, let's just start this one, we'll see what happens, and we'll talk about at the end. For the numerator in this case, I'm actually not going to distribute. That's one of the things I found out as I did this particular problem. It's actually easier for this problem to leave the top just kind of multiplied like so. So cosine of theta times 1 minus sine of theta. Again, not something you may instantly know to just do, but again, after doing this problem a few times, you may start to see some tricks in why that may be useful to, again, just not multiply. The bottom, the denominators, I will actually multiply together. So I have two terms that I'm multiplying, 2 terms in here times 2 terms in there. So I'll need to either do FOIL or the box method or however you multiply something like this. So I'll just start with FOIL and do the first term, so 1 times 1 is 1. The outside terms would be 1 times negative sine, which would be minus sine or negative sine of theta. The insides would be a positive sine times a positive 1, so plus sine of theta. And right away you probably start to see things canceling out and maybe think about why, again, we chose that fancy one to multiply by. And finally, the last term is positive sine times negative sine of theta would be a negative sine squared of theta. And if it helps you, think of these just in terms of variables if you're not sure what would happen if you multiply those. So think of sine as an x and then times a negative x. Well, x times negative x is negative x squared. Okay? So let's take a look and see what's going to happen, and then we'll hopefully get close to establishing this identity. On the denominator, negative sine plus sine will cancel out. And so all that's left in my denominator is just 1 minus sine squared. Okay? As soon as you start to see 1s and sine squareds, probably a good bet that you're dealing with a Pythagorean identity. And sure enough, 1 minus sine squared, looking at my identities chart, is the same thing as cosine squared of x. So I'm just going to replace the denominator with that. And again, the numerator I'll leave alone. I still won't multiply that out. Oops, somehow I changed my x into a theta. Sorry about that. Theta, that should be a theta. It doesn't matter what variable you use, just be consistent like I didn't do for this problem. So then my numerator was cosine times 1 minus sine of theta. And then taking a look, now that things have been multiplied, there's no plus or minus signs gluing pieces together, I can cancel out any common factors I have in the numerator and denominator. So I see a cosine of theta would cancel out on the top with one of them in the bottom. And again, think back to variables. If you had an x over an x squared, you can get rid of the one in the top completely and you'd be left with one in the bottom. And so then, rewriting this one more time, now that that cosine in the numerator is gone, I don't need the parentheses. I've got 1 minus sine of theta over cosine of theta, which I believe is where I was trying to get to. So sure enough, I've established that identity. So let's talk about why we chose this particular fancy one to multiply by and how you might know that when you have to start deciding for yourself. In this case, you may notice that what I multiplied by was almost the same as the denominator down here, just the sign in the middle was the opposite. It's something called the conjugate, and when you multiply by a conjugate, you get certain things to cancel out. So if you're in doubt of what you may want to try when you start establishing these on your own, maybe try multiplying by a conjugate. In fact, if we had chosen to multiply the other side by the fancy one and do this problem a different way, any ideas what you may have multiplied this by? And if right now you're yelling at your computer, 1 plus sine, you're right, that would also work. If we chose to multiply the left side by 1 plus sine of theta, we'd also have established the identity just in the reverse way, okay? And again, that trick right here was to not multiply. If you did multiply that, you would just have to refactor out a cosine in order to get them to cancel in the next step. So again, some things you may not know the first time you do a problem, but after you try a few of these, you may start to pick up some tricks.